Okay, so got a little idea here which has been kicking around for a while. The idea of, as you know, I use a lot of ATTinies, but they sleep very well and they don't use an awful lot of energy. But then I also had the idea of maybe if you do have to use a bigger processor, like an ESP8266 can use a fair bit when it's communicating, or an Attiny85 if it's doing something, recording data or whatever, then we can use maybe the Attiny13 as a sort of a watchdog. Keep an eye on the voltage of the system, and maybe use it to tell something like, let's say, an Attiny85. We'll just do proof of concept today, I guess. An Attiny85, let's say, maybe to write something to EEPROM for permanent storage before the voltage drops too much. So this is what I'm thinking. Let's hope I get blue ink all over me again. But anyway, so I'll just zoom in on that a little bit. Okay. So I am thinking of an Attiny13. So we've got VCC and we've got ground. Yes, not standard, I know. And then we've got, let's say an Attiny85, same. So VCC and ground. So then we're looking at, okay, this guy here is doing something. And so we've got 5 volts coming in and all's fine. Let's say we'll do something like, well, I guess, seeing as how I love blinking lights so much, let's say we've got a blinking light. And it's maybe counting. So it goes up something like, okay, I've got, I count 1, then I have a bit of a wait, then I count 2, then I have a bit of a wait, then I count 3, then I have a bit of wait, and so on, all the way up to maybe something like 20, and then restart again. So that'll just give us an idea of where we are in the sequence. So it's just blinking away, just short bursts, and we can see it counting. But oh no, the voltage starts to drop, and we want to keep track of where we are in the count. So what we're going to have to do is maybe send it a message. Now it can monitor voltage by itself, so that's not a problem. But I just thought it'd be interesting, you know, just as proof of concept for devices which can't, to maybe do something like, this is monitoring voltage over here, and then at some point it goes, hey, you're about to run out of voltage, you're dropping below, let's say, 4.5 volts. So it sends a message to the Attiny85. So maybe we've got, coming out of here, maybe we've got also something like a resistor LED combination which says everything's fine. Oh, this is going to get messy. There we go. And so this might be, let's say, a green light, green LED, and everything's good. And then what happens is that it says, you know what, things aren't good. So it sends a message to the Attiny85. The Attiny85 in turn writes to EEPROM. Then it tells this guy that they're, you know, that it's written. And then this guy then says something which shuts the whole thing down. So maybe we've got also something like some sort of transistory system that goes to the 5 volts. And I won't draw it like, I'll just say to, you know, just cuts VCC at this stage. So we'll set that up later. But this is just what I'm thinking, like, okay, so your main job is to look at after voltage, let this guy know that the voltage is dropping. And then this guy says, yep, no worries. I'm going to save where I am in the sequence. I'm going to let you know that I've saved. And then, okay, that's fine. Thanks very much. I'm going to shut you down. Pretty cool, I reckon. Let's see if it's going to work. So I will do some coding, and then we might come back and build it and see if it's actually working. I learnt, you know, the hard way, I guess, that these sorts of projects should be built up stage by stage, because, you know, if you just build the whole thing from scratch and then something doesn't work, there's a lot of debugging to try and figure out what's going wrong. So the very first step for me is to just get my Attiny13 talking to the programmer, and a quick blink sketch to make sure that I can get the timing of a couple of LEDs correct. So yeah, stage 1, all good. So now we have voltage hooked up via a little capacitor to PB3, and we're reading at around 5 volts. So I'm just going to lower that now and see what happens as the voltage gets lower. So around 4.5 now, 4.2, around 4. Oh, and there we go. So around 4 volts is the tipping point for this little program, and of course you can just adjust that as you see fit. Alright, so now we'll feed that signal out to an Attiny85. We might just check that Attiny85 is working correctly with writing to EEPROM first, and yeah, it looks like this is coming together pretty well. So next phase is to just check to see that the Attiny85 counts okay. So that's 1 flash, 2 flashes, 3 flashes, and so on. And we're still getting the Attiny13 monitoring voltage on the side there, but this is around 5 volts, so no big drama. So yeah, so what should happen now is that Attiny85 should keep counting up to 20, and then when it gets to 20 it should go back to 0. So really that's just simulating data coming in. Like for instance, if this was an ESP8266 weather station or something like that, or you were monitoring some analog levels around the place, light or whatever, then that's what it would be monitoring. But at this stage I've just got it counting because, for me the blinking LEDs are the best way of just seeing if the thing's working properly, because you can monitor the counts pretty well. You could also do like a serial output. Now, neither of these chips have serial, but you can do a software serial output and you can actually get numbers, and that's fine as well. Anyway, the count's gone back to 0, and it's going through that process again. So the next phase is to get the Attiny13 to talk to the Attiny85 such that if the voltage drops, the Attiny85 will go into writing the EEPROM and then shut down. Right, so here's the project. It's coming along pretty well, I guess. Just changed a couple of things. I took out an LED here that was marking the time or the counter, because it was just annoying really, and a bit hard to read. This is much easier to see what the counter's up to. We still have the Attiny13 here monitoring the voltage, and you'll see from the code that you can just change basically what voltage the cutoff will be. And you can also change your components here. I've just got a capacitor and a 10K pull down resistor around PB3. So yeah, by changing combinations of the code or those components, you can affect at what voltage the cutoff is. So the idea is that it's kicking along here, it's all pretty good, and then I'll drop the voltage, and what should happen is that this will swap over to a red flashing light. It'll send a signal through this 1K resistor to PB3 on the Attiny85, which will trigger an interrupt, and then that will the Attiny85 will save this number in EEPROM. Then it'll display low battery for 10 seconds. Then this display will go to sleep. The Attiny85 will go to sleep, and then that data will be preserved hopefully. So let's try that. So we're just going to reduce that voltage. So it's at 5.2 at the moment. That's going the wrong way. So there it goes, 4.9, 4.8, dropping, 4.7, 4.5, 4.3, 4 volts. Oops, and there it is, it's triggered. So the red light flashing on the Attiny13, the low battery indicator on the TM1637, which is about to go out, then that number is saved, and this now is asleep. Even if I raise the voltage now, so let's put that back up to 5, and we still see that the Attiny13 is still complaining that there was an interruption, so we know that, and we can see that it's dark anyway. But what I'll do is now I'll just flick that straight on. You could have a reset switch if you like, but I'm just going to flick it off. Let's say we're changing the batteries or whatever, reconfiguring the power supply, and you can see that number comes up to where it halted. So I'll just go through that cycle again, lower the voltage. So where are we? 5.7-ish, 5,700. So I'll just lower that voltage. Cutoff was around 4, I think. and should be getting close now. Then there it goes, low battery. Low battery indicator on the display, it'll disappear. That number will be saved. It's gone to sleep. The Attiny13 tells us there's a problem. I'll cycle that battery back up again. So let's go back up to 5 volts. That's nice and healthy. On and off. And there's that preserved count. And that's the circuit working.